Assalamu alaikum warahmatullahi wabarakatuh. I hope all of you are doing fine. So we were discussing the topic data representation and storage, and we have already discussed the representation of text in binary, and then we had a discussion over ASCII and Unicode, and then we had a discussion in the last class about sound representation, and we saw some benefits and drawbacks of sound, of having a higher sample rate of sound file, and then we saw how we can calculate mono file and stereo file size. So coming towards an conclusion of our topic, representation of data, today we are going to discuss the representation of images by a computer. Now more specifically, your syllabus or your book mentions representation of bitmap images instead of just images. That is because bitmap or .bmp file format is one of the oldest and most raw formats for representation of images. Now if you need to have a very high quality pictures, there are two options possible. Like if you take a picture from a DSLR camera, then originally that picture would be saved as a raw file. It would either be in TIFF or TIF format or in the BMP format. BMP stands for bitmap and TIF or TIFF stands for tagged image file format. Okay, so now what you need to understand first is that each image, how images are formed. Images are formed with the help of millions of tiny dots, which are known as pixels, as you can see here on the screen, and each pixel can represent one of the three primary colors, red, blue or green, or a combination of all three colors in order to represent different shades of different colors. And height or width of an image is always measured in pixels. Like if I place my cursor on any image, then it yellow pop-up box opens which shows me three things: item type, that is PNG file, which is not really our concern right now, and then it shows the dimensions, 1811 multiplied by 2953, which basically means that this particular image has a width of 1811 pixels and its height is supposed to be, or you can say the vertical height is supposed to be 2953 pixels. This dimension or the image size, it is always measured in pixels. Now if you may ask what a pixel is, then basically a single dot on a screen is pixel. You may see, you can't even see it. Let me magnify it, let me zoom in. If I zoom in, now you might be able to see this is 1 pixel. This dot is 1 pixel, and if I zoom out and come to a normal, see, you can't even see. So 1 pixel is that much tiny. Now I have a few images which I would like to show you. See, this is a representation of how your LCD or your monitor screen works. It has millions of boxes like this, and each box has three shades, red, blue or green, whereas some architectures like to depict it as a circular image. They say the pixel, 1 pixel is supposed to be circular. Again, it has three basic primary colors, red, blue and green. Regardless of whether it is a rectangle or a square or a circle, it always can represent three different colors, red, blue and green, and a combination of different shades of red, blue and green can give us up to 16 million colors, which is see, okay. Now that you know what a pixel is, the next thing you should know about an image is that which we have basically already discussed, that height or width of an image is always measured in pixels, and an image resolution is supposed to be the dimension of an image, means the width and height of an image written in pixels in something like this: 400 multiplied by 200. This basically means the width of an image is 400 pixels and the height is 200 pixels. This thing is known as image resolution. Now if you are given the height and width of an image in pixel as well as its color depth, then you can call that information as metadata. Okay, this would always be given to you in a particular question in your CIEs. What is a color depth? The number of pixels used to represent each pixel, the number of bits or bytes used to represent each pixel in binary is known as the color depth. The current standard which we have is 3 bytes or 24 bits per pixel, means the images which we have in our computers nowadays, those images are made up of pixels, and when they are converted to binary, then each pixel is depicted by 3 bytes or 24 bits. If we are talking about black and white pictures, then 1 bit represents 1 pixel. A 0 represents that there is no color, so it is white, whereas 1 represents color, that is black. Okay, 1 represents black, 0 represents white, whereas in color images we have 3 bytes or 3 binary values, 1 for each of red, green and blue, and the number of pixels in each image determines its resolution. If we increase the resolution, that means better image quality and larger file size, whereas if we increase the number of pixels or the resolution, it means lower image quality and lower file size. Okay, so we have discussed color depth as well, and as you can see, it's written here as well that nowadays we have 24 bits color depth, hence 16 million different colors can be represented, and if you increase or decrease the color depth of an image file, then its quality would also be increased or decreased. Now the next thing which you should know is how to calculate file size of an image. If you have been given a black and white image, I have depicted it with B/W, black or white, then the formula is image height in pixels multiplied by image width, which would again be given to you in the question in pixels, divided by 8. In order to find for black and white image size in bytes, because whenever a question comes to measure the file size of an image, the least unit you would be asked to give your answer in would be bytes. If you have been asked to let's suppose represent your answer in kilobytes, then simply over here add 12024 in the denominator. This would give you answer in kilobytes. Or okay, if you have been given a colored image, then you can simply follow this formula: image height in pixels multiplied by image width in pixels multiplied by color depth in bytes, and this would give you the answer in just this part would give you the answer in bytes. Okay, but obviously nowadays we have bigger images, so the examiner is going to ask you to write down the answer in at least kilobytes, and for doing that you can simply divide the answer by 1024, and this would turn the answer in bytes into kilobytes. Or if the examiner asks you to find the answer in megabytes, then simply add another 1024 in the denominator and you would get the answer in megabytes. Okay, but as a standard, you are going to get the question to write it in kilobytes or kbs. Okay, So just remember these two formulas for finding image files, for finding the size of images in bytes or kilobytes. They are given in your slides as well over here. Okay. Now the next thing which we need to discuss is the measurement of data storage. Now you might be familiar with the kilobytes, megabytes, terabytes, gigabytes and petabytes and so on, but there was a problem with that old system. That system was based on the SI units, and as you know, in SI units 1 kilo is supposed to have 1000 units of a measurement. Exactly 1000, not more than that, not less than that. Whereas, so basically 1 kilobytes of data should have had 1000 bytes, whereas in reality we have 1024 bytes. This was causing a problem. Internal memories such as hard drives and your RAMs, they were using 1024 bytes as a 1 kilobyte, whereas the manufacturers of USBs and other storage devices, they were still following the SI unit, and they would say, okay, no, if you have 1000 bytes that means 1 kilobyte, and if you have 1000 megabytes that means 1 GB. That is why if you would buy any USB from the market, let's suppose a USB of 8 GB, then and you plug it in your system, then you would see that actually the file size, the size of that USB or the usable space on that USB stick would be 7.7 or 7.8 GBs and not actually 8 GBs, because the manufacturers were considering this part, that 1 kilo is supposed to have 1000 units, so 1 GB is supposed to have 1000 MBs, whereas in reality 1 GB is supposed to have 1024 MBs. Thus, according to them, 8 GB means 8000 MBs, whereas in reality, or according to the hard drive storage, 8 GB is supposed to be 8 multiplied by 1024, that is supposed to be 8192 MBs. In order to solve this confusion, the IEC, the International Electrotechnical Committee, has developed a new system for measuring data units, which is given in the slides. This is the table for that. Now they have basically changed the name of the units as well as their symbol. Bit we already had, it is the smallest unit, it is either a 1 or a 0. Okay, and then they have introduced the concept of nibble. In the old system as well there was the representation of nibble, but the old system would say that any number of bits smaller than 8 is supposed to be a nibble. Means if you have 5 bits, 4 bits, 6 bits, 7 bits, then it would be called a nibble. Now they have basically fixed the number of bits that each nibble would have. Now they say if you have 4 bits, then you have 1 nibble, and 2 nibbles are equal to 1 byte. Whereas you already know 1 byte is supposed to be 8 bits. Now the next part, we were supposed to have kilobyte over here, that if you had 1024 bytes, then we would say that it is 1 kilobyte. Now they have changed the name and they say it is kibibyte, and the symbol is capital K, small I and B. So 1 kibibyte is supposed to be of 1024 bytes. 1 mebibyte, previously it was supposed to be megabyte, now it is mebibyte. It is supposed to be of 1024 kibibytes. 1 gigabyte is supposed to be of 1024 megabytes. 1 terabyte is supposed to be 1024 gigabytes. 1 petabyte is supposed to be 1024 terabytes, and the last unit which we have is 1 exabyte, that is supposed to be of 1024 petabytes. Okay, now this new table of representation you should memorize it, because in your syllabus the syllabus for 2210 year 2023, the examiner is going to ask you to convert using these units, as well as the examiner is going to need your answers with these units. If you write KB or MB or kilobyte or megabyte, then the examiner may not award you full marks, and he is going to need your answer in according to this new format. Next, we are going to have a look at a few practice questions. Calculation of file size for an image. Let's suppose you have an image that is to be stored on a computer's hard disk, and you have to work out the total file size in kilobytes. See, this is an exam style question, and as you can see, the examiner has asked you to to use the unit, the new unit kilobyte, and it has given you the metadata. Use the following information. See, they have given you the metadata that the number of horizontal pixels is 480 and vertical pixels is 400, means this is the width and height of the image, and the color depth is also given to you, that is 16 bits. Now these 2 points and these 3 values, they are the metadata for the image. Now if you have to calculate, now using this data, we can apply the formula which we have already discussed, and we can calculate the file size, such as 480 multiplied by 400 equals to 1,92,000, and that gives us the total number of pixels in our image, in this image. And then we will multiply it with the color depth, and the colored, it can either be in bits or bytes. Now if you would like to go ahead in bits, then you just write 16 as it is, but then you'll have to divide the answer in the next step by 8, because the examiner is never going to ask you to write the image size in bits. The least unit the examiner is going to ask you of is bytes, so we'll just write the color depth in bytes. 16 bits means 2 bytes, and we'll modify the formula to be in bytes as well, and this gives us the answer of 3,84,000 bytes. And in order to go to kilobyte, as you can see in the table, 1 kilobyte is supposed to be 1024 bytes, so we simply divide the answer, means the file size in bytes, by 1024, and that gives us 375 KIBs or kilobytes. This is our final answer, the image file size in kilobytes. Question number 2. An audio CD has a sample rate of 44,100 Hz and a sample resolution of 16 bits. The music being sampled uses 2 channels to allow for stereo recording. See, if the word 2 channels is there, that means 2 mics are being used, hence it is a stereo file. Calculate the file size for a 60-minute recording. You already know the formula from the lecture about sound files. If you have a stereo sound file, you will multiply the sample rate, multiply by sample resolution, multiply by 2, multiply by length of sample in seconds. We have already discussed the formula in our previous class. So using that formula, first of all, this is the formula written over here as well. Now for finding the size of sample, first of all we multiply the sampling rate, multiply by sample resolution, multiply by length of sample in seconds. Now it is over here in the question, the length is given in minutes, so we just multiply with it with 60 in order to find the number, the length of the sample in seconds, because in 1 minute there are 60 seconds. So we got the answer as this: 2,540,000,000. No, it is actually higher than billion. This would be unit 2,540,000,000 and 160,000 bits. and since this is a stereo file as mentioned here that it uses 2 channels, then we'll multiply it with 2. So this gives us 5,080,000,000 and 320,000 bits. Divided by 8 to find the number of bytes, so that would give us about 635,040,000 bytes. This would be in bytes. Now if you don't want to do this step, if you want to skip this part, then what you can simply do is, instead of 16, just write here 2 in the first place. Means write the sample resolution in bytes instead of bits, and you can skip this part. Then you can skip this part. This part. You'll not have to divide it by 8 in the next step. And finally, once you have the answer in bytes, divided by 1024, multiply by 1024 in the denominator and convert it to MIBs or MB and that would give you the answer as 605 MB. Now what I want you is this table as well as practice question number 1 and question number 2 should be there in your copies, and then you are going to do this assignment in your notebooks as well. These are 2 questions. In question number 1 you have to calculate the file size in KB of an image file, and in question number 2 you have to calculate the size of a sound file in MB, and the appropriate data has been given to you in each question. Alright, if you have any problem, feel free to ask me. I'll see you in the next class. Take care. Allah Hafiz.